Hey everyone, we are going to work our way through the multiplication and volume checkpoint today. Put your name and number up at the top. Remember, my requirement for these tutorials is everything I do, you have to do. So I write something down, you should as well. Throughout this video, I'm going to give you guys a couple of secret codes that I want you to do. I want you to make sure that you're doing all of these secret codes, and if you do and turn it in, you will earn a Best of the West quick ticket. All right, let's look at number 1. Brad found this box for baseballs in the basement. How many baseballs does the box hold if one baseball fits in 1 unit by 1 unit by 1 unit space? They're saying one baseball fits in one of these little cubes. And it's saying show your work. The question is how many baseballs? Here's the box. How am I going to solve this problem? What I need to do first is I need to figure out what are the dimensions of my box. So from here to here, what are the dimensions? 1, 2, 3, 4, 5. Record a 5. From here to here, what are the dimensions? Ooh, that's a big number. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Record it. And then I need to know the height. How tall is it? So from here to here, count carefully. 1, 2, 3, 4, 5, 6. That is the dimensions of my prism or my box. Now I need to figure out how much will fill it up. That's volume. We're fitting in baseballs, but that's volume. So when I figure out volume, I'm going to multiply all of these together. So my base is a 5 by 18 base. My height is 6, so 6 layers tall. So here's my multiplication equation. Now, typically I need to do parentheses first, but in this case, since multiplication, I can move around my parentheses and solve them in any order I want. I'm going to make this a little bit easier for myself. I'm going to take 5 times 6 first, and then I'm going to multiply it by 18. Go ahead and rewrite our equation. 5 times 6 is 30. Keep my 18. 5 times 6 equals 18. All right, I'm going to do a doubling and halving strategy for this one. I'm actually going to double this number, which brings me to 60. I'm going to half this number, which gets me to 9. This problem is a lot easier for me to solve. What's 6 times 9? 54, and then I attach a 0. So my answer is 540. And I'm going to label it cubic units. Cubic units. Then it says write an expression to describe a different box that would have the same volume. So I need a different box to equal 540. Has to have different dimensions. Well, first, what did I get that got me to 54? I took a 6 times 9. So what if my base on my box was 6 times 9? Because that gets me to 54. And then let's say my height was 10. That's where I attach my 0. This would be a different box that I could create that would have the same amount of baseballs it would fit. Remember, if I'm going too fast at any time in this video, you get to pause it to catch up. All right, let's go to number 2. Brad found a large box that holds 72 balls in one layer. Let's put a box around 72. If the box has 5 layers, how many baseballs can the box hold? Show your work. So I know that one layer, my base, is 72. So my base is already 72. My height is 5. This is my height. That's how many layers it is. So now I need to take 72 times 5. I know a strategy. I could take 72 times 10 and then cut it in half. That's my 5 strategy. 72 times 10 is 720. Now to cut this number in half, here's what I think of. I think of 720 as being 700 plus 20. What's half of 700? 350. What's half of 20? 10. Now I add these together and I get 360. And how am I going to label it? I think we're talking baseballs. And I'm going to circle my answer. If the box can hold 1,584 baseballs, how many layers does it have? Show your work. We're going to set up a ratio table. It's kind of a tricky problem. Up here is going to be layers. The bottom is just going to be baseballs. Now we know from earlier information that one layer holds 72 baseballs. So I'm going to record that. We also just figured out that 5 layers has 360. We did find out that 10 layers, we took 72 times 10. 10 layers would be 720 baseballs. Now I'm trying to build my way up to 1,584 baseballs. I'm trying to build my ratio table to that. So I need to get this number to there. What could I do? Let's double it. Let's double 10. Let's do 20 layers. 20 layers would be 720 doubled. What's 720 plus 720? It's 1,440. I'm getting closer. What if I added one more layer to that? I wish they gave us more space. What if I added another layer? I'd have 21 layers. That means I add 72 to this. So I'm trying to add 1,440 plus 72. 0 plus 2 is 2. 4 plus 7 is 11. Here's where I put my 1. Here's where I put my 1. 1 plus 4 is 5. Oh, I'm at 1,512. I'm super close. That's 21 layers. Let's do 22 layers. What if I added 72 more? Another layer. 2 plus 2 is 4. 1 plus 7 is 8. 5. We hit our target. We hit 1,584. What is my answer? How many layers was that? It is 22 layers. Circle my answer so I can see it. Pause it if you need to get caught up. Your first code. Up in the date box on your paper, I want you to put a star. That's your first code. All right. Number 3 says, write an expression for each statement. Expression is just a number sentence. We don't even have to solve. Perfect. So this is a student's thinking. To solve 49 times 73, this is the problem they're trying to solve. I multiply 73 times 50. So let's show that thinking. 73 times 50, and since that's first, I'm going to group it together with parentheses. And take off. When I take off something, I subtract. One group of 73. Here's how I show one group of 73. That's one way to show it. Or I could do the same thing, but just subtract 73 like that. That's my expression. I don't even have to solve. Letter B, to find 15 times 16. That's the problem we're trying to solve. I double 15. So if I double 15, I'm going to take 15 times 2. And then I'm going to half 16. I'm going to take 16 divided by 2. And I'm going to multiply them together. So I could leave this as my expression, or I could actually double 15, which is 30. And I could half 16, which is 8, and I could leave it like that too. Either one would work. All right, for your next code, I want you to put 3 dots in the bottom right corner and flip it on over. Number 4 says, write true or false next to each question. I'm looking to see what did this student do to solve the problem. So this student appears to have tried to double 76 to get to 152. Is 76 doubled equal to 152? Yeah. Then this student tried to take this number, 42, and half it to get to 21. Is half of 42 21? Yeah. Use the doubling and halving strategy. Record that. And they did it correctly, so that is true. That will work. All right, next one. The student was given this problem, and this is how they thought through it. Instead of 199 times 68, they said 200 times 68. Okay, so far so good. They're doing an over strategy. And then, once they went over, then they added a group of 68. So they went to 200 times 68 and then added a group of 68. Is that what they wanted to do? No, that won't work. It's supposed to be subtract a group of 68. They were close. All right, number 5. A crate to ship boxes of baseballs can hold 4 boxes that are each 6 by 6 by 2 each. So each box, that's the dimension. How many baseballs can be shipped in the crate if each baseball takes a 1 by 1 space? So that's if each baseball fits in a cube. So they're asking the question, how many baseballs? They're giving us an action. Show your thinking. Okay. So first, I'm just going to sketch out one of these boxes, just one. Go ahead and sketch one out. And they told me that each box is a 6 by 6 for the base by 2 dimension. Okay, now remember, this is one of them. How many total boxes are like that? 4. So I'm going to take this times 4. Whatever I figure out times 4. Okay, let's figure out the dimensions of just one of these boxes. 6 by 6 by 2. I think I can do it in this order. I kind of like that. 6 by 6, 6 times 6 is 36. 36 times 2 is the same as 36 plus 36. 6 plus 6 is 12. 3 plus 3 plus 1 more, 7. So there's 72 that fit in one of these, but I need to take it times 4 because I have 4 of those, 4 boxes. So I'm going to take 72 times 4. What's a good strategy for my fours facts? Double a double. So first I'm going to double 72, and then I'm going to take that answer and I'm going to double it again. I'm doubling a double. 72 times 72, or I'm sorry, 72 times 2 is the same as 72 plus 72. If I add them up, I get 144. But now I need to take that times 2. That's the same as 144 plus 144. And what do I get when I add all of these up? 288. And how would I label it? Baseballs. Last step, circle it. Okay, your next code is to buy number 6. Put a smiley face. Number 6. Fill in the bubbles to show which statements are true. So if we think it's true, we fill it in. Volume is measured in square units. Nope, we didn't use square units on the front side. We did not do that. That one is incorrect. Volume is measured in cubic units. Yes. A cube with an edge length of 1 unit is called a unit cube. They're saying that one of these tiny little things that just has a dimension of 1 by 1 by 1 is called a unit cube. That is true. We haven't talked about that a lot, but that is true. When you measure how long something is, you're finding its volume. Is volume finding how long something is? No, it's finding how much you can fill in the inside. A cube with an edge length of 1 unit has a volume of 1 cubic unit. So one of these tiny cubes, if it's a 1 by 1 by 1, if I multiply those together, I get 1 cubic unit. So that's true. And the last one, when you pack as many same size cubes as possible into a box, you're finding its volume. So when we're putting baseballs into the box, are we finding volume? Yes. All right. The last thing I want you to do as part of your code is go back to the front side and put a box around your name. And then you're going to turn this into the math basket and then go on to the next video link in your email. Thanks, guys.